So let's take a look at example number 1. Example number 1 is 6k squared minus 11k minus 35. Now what I'm going to do is I'm going to try to go through and I'm going to try to show you some of the little tips and tricks that we can do to find our values really quickly. And we're gonna try that out. 6k squared, if we factor it, it'll be k times 6k or 2k times 3k. And then we could do the negatives as well. But the negatives for the first one are not usually necessary. We often want to try to keep the first one to be positives. So we're not going to really look at the negatives too much in this case here, or at least we won't try to. All right, negative 35 is 1 times negative 35, 5 times negative 7 times 5, and negative 35 times 1. All right, we want to find ones that add up to negative 11. Okay, so here we're going to have a positive and a negative, and here we're going to have two positives. So we're going to have a bigger positive end value and a smaller negative end value, and we want to try to find ones that work out nicely. Now some of you, it'll take a little bit to see this. Some of you just won't be able to see these right away, but I'm going to go through a really quick way of doing logical reasoning, as it can become something that is really helpful. Now, if we do k and negative 35, it's going to be negative 35, which is way bigger than negative 11. Okay, the 6 and the 1 multiplied together aren't going to come even close. So this is, and then if we do 6 and negative 35, that's a massive number. That would be like 210. So that's not even anywhere close. So we're not going to put those two together. The big negative here really kind of messes us even with these here. So it's probably not going to work. So what I'm going to do, based on what I saw there, I'm going to use these two right here, okay? And before even writing them down and making a mess and then having to do another one, I can do some really quick mental math here. 2 and negative 7 is negative 14, and 3 and 5 is 15. Really close. It's not going to give us negative 11. 2 and 5 is going to give us 10. 3 and negative 7 is going to give us negative 21. If we add those together, we get negative 11. So that's the one I'm going to multiply together. So I'm going to do 2k and 3k, and then I'm going to multiply the 2 by the 5, so I'm going to put the 5 on the bottom and the negative 7 on top, as such. Okay. So again, this is just seeing the patterns and kind of going through this. Now, I've done a lot of these, so I see these patterns quickly. As you do more and more of these, you start to see more patterns, and it's important not to try to compare yourself to someone who's done a lot of these right away. Okay, so if we multiply these two together, we get negative 21k, and if we multiply these two together, we get 10k. We add, okay, negative 21 and positive 10 gives us negative 11, and that is the value that we are looking for. So then we take this pair and we take this pair, and these are our two binomials. 2k minus 7, okay, we have to keep that sign there. Okay, we got to keep that sign, and 3k plus 5 are going to be our two binomials that we're going to be using. So this becomes our factored pairs, okay, for our trinomial. Now, if you'd like me to show you some more of these, please just shoot me a line there and let me know. I can definitely show you some of these. I've got 2 more examples that I can fill out. If you are completely confused by this, just go back to decomposition. I find that way to be a little bit more straightforward and a little bit more one kind of step by step that does sometimes work a little easier.